Hello, everyone. Welcome to this startup school session about practical AI and ML. My name is Zach Akil. I'm coming to you live from sunny London, and I'm going to be guiding you through the next hour. And hopefully, by the end of it, you'll all know a bit more about how to practically use machine learning and a lot more about all the different tools that you can use in your startups right now to do that. So that's the promise by the end of the session is you're going to know about brand new tools that you've never heard about before, and you're going to see them in action. So you're going to know how easy some of these tools are to use immediately. To give a bit of background on me, my name is Zach Keel, and my role at Google is a machine learning developer advocate. Now, I've been doing this role for about 5 years, and what I basically do is I focus on finding the practical uses of new technology. And sometimes these uses are a bit silly, but every time I try to find a new use case, it's always trying to showcase the strengths of the technology and in a domain where it actually should be used versus just trying to shoehorn in machine learning for randomness. I'm all about trying to find the practical uses for the real tools. Now, to show some examples of the things that I've done, I've got some demos that I've previously built. One of them was a smart bicycle. So if you cycle in a busy city like I do in London, you'll be aware that it can be quite scary sometimes as a cyclist. You might think that you need to have eyes on the back of your head to actually do it safely. And that's exactly what I built here. So I used real-time object detection running on a bicycle using a Raspberry Pi and some TensorFlow models. And the idea is that it would run object detection. So it would detect when there was traffic behind you. And then not only was it detecting that there was traffic, it was actually identifying the different types of traffic. So it was able to warn you about the levels of danger that are behind you in real time. Now, what was cool about this is we were actually leveraging a special bit of hardware called an Edge TPU that Google makes. And this was able to run the models at super fast real time, like way faster than you can ever run them on just a Raspberry Pi alone. I think by itself, a Raspberry Pi could make one prediction a second. When we plugged in this special device that Google made, it was running at 60 predictions a second, the exact same model, but using this special hardware. And I believe like this is a perfect example of the kind of thing I do. Like I try to find the use cases where actually to solve this problem, that is the only technology available to solve that problem. Like is edge-based machine learning that's accelerated, because in this technology, we needed machine learning running on a remote device because we didn't have access to internet or power, and we needed to run super fast. So that's a kind of example of how I've been thinking for the last 5 years. Now, how this applies to startups is interesting because before I worked at Google, I worked in multiple startups, and the most recent one, I worked there for a couple of years as a software engineer and then a data scientist. And what's very interesting is we had a lot of problems back then where at the time, as a data scientist, I think for certain projects, I was spending a couple of months trying to solve a specific problem with machine learning. And what was funny is when I started at Google, because of the nature of the job at Google, where I'm just trying to discover new technologies and see where they're useful, when I started at Google, in the first week, I learned about a tool that would have turned 2 months of work beforehand into roughly 2 days. So this is like the power of knowing the right tool to do the job. And especially in the field of machine learning AI, by far, I feel like this is the fastest moving technology field within the field of technology, which is already a fast moving field. So it's like fast moving squared in terms of how quickly research applications are becoming like developer applications in terms of feasibility to build. So like, especially with the advent of LLMs and chatbots, within the span of a couple of months, research projects have now become developer projects. And in fact, they've even become like consumer projects where you don't even need to be a developer. You don't need to know how to use an API to do something which would have taken a team of researchers months to research and build. So that's why it's a very exciting time. So good job on coming to this session where you're actually going to learn about some of these modern tools that can be used quickly to solve problems. And yeah, keep your eye out in terms of the best thing to do within this field of machine learning in terms of practical machine learning as a startup is just keep learning about new tools. I like to think of it as practical product knowledge. So you don't need to necessarily know how to use the tool, but just knowing that the tool exists is the most useful bit of knowledge that you could have, because if you do need to use the tool, you can work out how to use it. But just knowing that, okay, this tool exists and it's good for this thing. And that's exactly what this session is going to go over. I'm going to go over a whole host of different tools, what they're used for. I'm going to show off some. I'm even going to build some machine learning models. In this session, I'm going to build multiple machine learning models using some of these tools that we've got. So yeah, let's continue on. I've got another example of using machine learning for football analysis. This was using cloud-based machine learning to do all the processing in the cloud for like sports use cases. And then last one was a bit silly, but also kind of interesting in that it was a food classification robot. So you put a snack on your desk. Based off of if it's a healthy or unhealthy snack, judged by an AI model, a robot arm would swipe it off the desk. Now, this is one of the more silly ones. But what's interesting is when I built this model at the time, it took me about a day, hence the like craftsmanship of it. But even back then, like I was using a tool that right now, in fact, I'm going to show the tool in this session that could have built this even faster. I could have built this thing in less than an hour using the tools that I know about now. So that's what it's all about. It's all about learning the tools that are going to enable you to actually solve problems quickly. So let's get started. So the agenda for today, I'm just going to go over a bit about the logical thinking process for practical machine learning. So the top one is, when should you actually think about machine learning? Then it's how to decide what tool to use. And then I'm just going to go through a whole host of just live demos, because I think that's the best way to see this stuff in action. So I'm going to show demo after demo of different things. It's going to be a lot of demos, a lot of stuff to remember. I'm going to have some links at the end, but if you see a demo that you like or a tool that you like, I would jot it down as well, because I'm going to be flying through these really quickly. But let's get started. So the first question that you should be asking is, if you've got a problem, you should think, okay, when should I think about using machine learning to solve a specific problem? Now, there are a couple of key problems where machine learning is thriving in, and those are problems that involve images. So yeah, anytime you're working with images, potentially there's a use of machine learning there, whether it's automatically detecting what's in the image or classifying the image or detecting if it's a safe image to upload onto a website. So anytime you're working with images, image search, that sort of stuff, usually machine learning is going to help a lot there. Natural language. So anytime you've got a block of text, so this could be a product review that's just written out as a paragraph. Anytime you've got natural language, that's going to be an indication that maybe machine learning could be useful here. And what's interesting, these two data types, very popular data types, especially natural language. When I was working in my previous startup, it was basically a data science consultancy. And most of the problems faced by businesses that were machine learning problems always involve just they have loads of natural language text sitting in databases somewhere that isn't producing any value. So they want to use machine learning to kind of get some like leveraged insights about it or generate some value from it. So yeah, if you've got natural language already in your business, potentially you could use machine learning for it. Now, these two data types that I talked about, natural language and images, those are what's called unstructured data. So by themselves, they can't be easily analyzed or queried, etc. So when we think about structured data, we think about tabular data. That's data in a spreadsheet or data that's sitting in like a relational database. So that's structured data. Structured data is great because it's already basically structured. It's structured for a computer to easily query and understand. If I want to query to find like what's the most value in a certain column, what's the most amount of sales we made in a certain month, that's easy to do as is. When it comes to unstructured data, maybe it's what's the most number of dogs in all these images. We can't just query that unless we've used machine learning first to detect all the dogs and that sort of stuff. So that's why we think of natural language and images, video, audio, all this kind of data is unstructured because we can't easily query it. And things like tabular data, databases, that's all structured data. And the whole point of machine learning is to take our unstructured data and turn it into structured data. At least that's most of the use cases of machine learning, is taking whatever is in this image and outputting a structured, whether it's an object in code of what's in the image or what is the text that's detected from a document using OCR. All that stuff's around getting from our unstructured data to structured data that we can then leverage to develop some insights. So to answer the question, it really just comes down to data. So anytime you've got data, potentially you could be using machine learning. And the word there is potentially. Just because you have data doesn't mean you should use machine learning. There is an example of a problem that Google solved within Gmail a while ago, and you might have experienced this feature where if within an email you're typing to someone and you say that you've attached a document and you haven't attached a document, Gmail will warn you and say, oh, we think you meant to attach a document. And because this is natural language, you've typed out a whole message. You might think, oh, this is probably solved by machine learning. Like we could train a model to detect, okay, do I need to attach a document given this block of text? And you could. The answer is yes, you could train a model to do that. However, a simpler solution would be just to look for the word attached in the text block. So we can write an if statement, so a single line of code to say, given this block of text, does the word attached appear in it? So you don't need machine learning to do that. And that actually solves the problem. 99% of the time, if you use the word attached in an email, people want to attach something or they're referencing that they've attached a file. So that's an example of just because you can use machine learning doesn't mean you should. So it's really important to think about whether or not machine learning is actually a good use of your time, because it can be, like I said before, my time in the startup, we invested months of time, months of developer time to solve a problem which could have been solved by another tool, but potentially it could have been solved by even just some code or something else. So it's always worth considering, do you actually need to use machine learning? Because it can be, especially if you go down the wrong path using the wrong tool, can be a huge sort of time sink. And I guess definitely my experience in the startup has taught me that limited resources, you do not want to waste your time. Your time is more valuable than any other company's time. So make sure you're very cautious about investing time into a machine learning project unless you know they're using the right tools and machine learning is even the right option for it. And if so, using the simplest tool for the job. And that's the next question is, which technology to use, which machine learning technology? If you have identified that, okay, we have this problem, maybe it's analyzing unstructured data, and now we want to work out what machine learning tool should we use. And my approach to this, I've kind of alluded to it, but the previous thing I've just said is it's always better to use the simplest tool for the job. Later in this talk, I'm going to show a demo where we're using a very complicated tool to solve a problem, and then we're going to use a very simple tool to solve the problem. And they can both do it, but that's why it's good to know about both of them. It's good to know that this one can do basically everything, and that this other tool can be used to do this specific task, but it's a lot simpler. So it'll be less time consuming. It's going to be more accurate over time, more robust. So yeah, the rule of thumb is which technology to use. Use the simplest one. Use the simplest one that you have the most experience with. So it's always the simplest tool for the job, especially machine learning, is better. And even if you're a data scientist, the rule of thumb is which model to use. It's always the simpler model. If there's a simpler model that solves the problem, that one's going to be better. So simpler is better in general. Okay, so we've talked a bit about the way of thinking, like when should you use machine learning? If so, which tools should you think about using? And now I want to think about in terms of the problems to solve. I think most people will agree that problems can kind of be fit into two different categories. So we've got tasks. So these are one-off problems. So especially in my startup days, it was, oh, we need to do this thing really quickly, whether it's processing like files automatically or just doing this quick task. I've had friends who work in research and they have a lot of tasks. It's a lot of task-based work. It's work that they just need to do once and then they'll never do it again. So I want to highlight the tools that are really good for doing tasks. And at this point in time, I want to sort of invite people, like, feel free to pop your questions into the chat. And then at the end, I'm going to answer some of the questions. So if you've got any questions along the way, feel free to put them in the chat. And at the end, I'll answer some of the questions. But yeah, first thing is tasks. Things that you only need to do once and you don't need to repeat. Then we have apps or systems. These could be the actual product that you're making. These are things where we know we want to use machine learning to solve this problem, and we're going to want to solve the same problem again and again and again at scale, potentially with thousands or millions of users calling these models. So it's important to know about the AI tools that can do this sort of thing. There's a sharp divide between the tools. There's actually not. Some tools can do both. Some tools are simple and can run at scale. Some tools are just simple but can't run at scale. And some tools are complex and only run at scale. and I'm going to be covering all three. You're going to see examples of all three, and I'm going to highlight this one's good for tasks, and this one's good for apps. So with that, I've covered when we should think about using machine learning, what kind of tools we should think about using, and the kind of tasks that we can use to solve machine learning. All in the abstract. Let's get concrete with it. Let's just look at, we're going to spend the rest of the hour just looking at demos. So I'm almost going to saturate your mind with loads of examples of how these things can actually be put into use. So let's get started. The first genre that we're looking at are text-based problems. So I've got an example use case here. Imagine you've got loads of customer reviews about a product, and we want to analyze these intelligently. Well, first tool that's important to know about is this natural language API that Google has. So I'm going to switch over to the demo. If you search natural language API, Google Cloud, there's a lot of them. Google Cloud has one, and you'll get to this product page. And what's really nice is that this has a built-in demo. So if we were to put in a customer review here and hit analyze, this isn't a customer review, this is just a demo text. But what it can do without you having to train a model or set up infrastructure or anything, as a pre-trained API, so the model has already been trained, you don't need to train it, it will detect all of the entities that are mentioned in your document. So if this was a product review, it might be detecting all the different features that people are talking about your product, whether it's the keyboard or the case or whatever. So they would detect all those. So we can say, oh, people are writing reviews about these things about our product. Maybe we should look into those. But it can do something really cool as well. Built into this API, it's got one of the most common text-based ML problems. In my days working as like a data science consultant, the most common problem people wanted to solve was doing sentiment analysis on text. So it has that built right in. So it will tell you the overall sentiment score for this document. So if people are talking negatively about the product, it will give it a negative score, or a score between 0 and -1. If people are praising the product, it will be from 0 and +1. But not only in the API will it tell you the overall document score, what the Google API does very specifically and very well is that it gives a per entity sentiment analysis. There may be other tools that do it, but in my experience, this is the only tool that I've seen that actually does it. And it will identify what's being talked about individually and also what level of sentiment it's being talked about within the document. So if this was a big piece of text about a customer review or a review about your product, it would say, oh, maybe the interface was great. It would get a positive score there, but the sign-in form wasn't working, and it would show that as a negative thing. So it would automatically detect all that for you, and you could convert your reviews into structured data, and you could itemize them about, oh, they talk about this product the most, and the summation of that is, oh, this product's very negative, or this feature that we have is seen as very negative. And this is a example of an API that's good for both tasks and apps. So you can call this one-off on a couple of documents, or you can call this a million times on a million documents. So it's a really good example in terms of if you want to do sentiment analysis on any kind of text that's in a database or even in a web app, it's an API that you can call from anywhere, and it will do this powerful feature, which I think is really useful, which is an entity-based sentiment analysis. So that is tool number 1, natural language API. The next thing I want to talk about, that was an example of a pre-trained model. So that's a model that's already been trained. You don't need to supply your own data to it. Now, maybe you've got a problem that can't be solved by that pre-trained model, but you have a custom domain. Like maybe you want to do kind of classification on text. So given a piece of text, you want to sort of almost cluster them together to be like, okay, these pieces of text are relating to this category or this category. You want to label text so you can maybe search it better. That's where natural language comes in, or natural language AutoML. Now, AutoML is a family of tools that's on Google Cloud, and it enables non-machine learning experts to build their own custom models that are enterprise grade and can run at scale. So here is what this looks like. So within the Google Cloud Console, it's full screen. Within the Google Cloud Console, It looks like a lot's going on here, but I'm looking at a data set that I've uploaded to AutoML natural language. And this data set specifically is about movie genres. So there's a description of a movie, and then the output, or what we want the model to predict, is the genre of the movie. And it can be multiple genres. So I haven't needed to clean the data. Well, actually, I did need to upload it in a CSV format, so that bit needed to be structured. But once it's in there, I can basically train a brand new model by clicking 1, 2, 3 buttons. I can click Start Train, and it will start training a model in the cloud, and it will do all the things that a machine learning engineer should do to train a good model. After it's done training, you'll be able to look at its performance, and then you'll be able to deploy it into your applications. And right in the UI, you can test it out. So let's see. I've got to come up with a movie. I don't know. A epic car chase for stolen gold. Here we go. That will win an Oscar. That is mostly action, bit of crime, bit of comedy, bit of drama, adventure. There you go. So we've generated, or we predicted, the genres for this one sentence movie, all with a model that's been trained in the cloud and deployed at scale. Now, a thing to note about this is an example of maybe it's more app-based than task-based. Actually, you can run batch predictions. When it's deployed live, it is using compute. So if you've got the need for this to be running in an app or to have it called thousands of times in real time, this is a good use case. If you just need to use it as a one-off thing, you can use batch prediction. So it'll only spin up the model, make its predictions, and then turn down the model. So it's a very cheap way of running this tool. But yeah, AutoML, natural language. If you need to train a custom model yourself on your own data, but you don't have ML expertise in-house, you can use this tool, and you know you're going to get high-quality enterprise-grade model, basically doing all the proper ML stuff in the box for you. Last thing I want to show, PAM API. Now, this session is not specialized in generative AI. There's going to be another session for that. But I'm just going to quickly touch on the PAM API because this is an example of a very powerful tool with a lot of capabilities. However, if you're looking to use it, you might want to consider simpler tools that already do what you're trying to do. So an example of something we might want to do with the PAM API is we might want to do the thing that we did with the natural language API. So this sentence, maybe we want to do entity extraction with this sentence, and we come over inside the Generative AI Studio in Google Cloud, click on language, go into the prompt, and this is now we're in the PAM API, and maybe we want to do extract all the entities. So I can go extract all of the entities of this text and return them as a comma separated string. So spelling is secondary. But if I said, let's say I wanted to solve this problem and I only knew about this tool, well, this tool would do it, but the previous tool did this with sentiment analysis built in, and I'm sure I could write out the prompt. I could come up with the prompt to do then that and like maybe do sentiment analysis and then return it for each bit. It would eventually work. It would eventually do what I wanted to do, but it's a lot of work for something that the natural language API already does and that can run a bit quicker. It's a bit more performant because it's a simpler model. So that's an example of the PAM API. It can basically do anything you want with text. But if you're trying to do something with it that you can solve with a simpler API, that's probably going to be a better bet. It's going to be a quicker return in value, and it's going to be more robust to run at scale. So that's a bit I want to touch on in terms of it's a very cool, complicated tool or complex tool. It's not complicated to use. You saw it's quite easy to use, but it's a very powerful model, and it should be used with hesitation if there's already a simpler model or a simpler tool that can be used to solve it. Okay, that was text-based problems. Moving on to my favorite domain, images. Let's assume we've got some images or a big bucket of images, and we want to filter out all the ones that show people in it. Well, a lot like the natural language API, we have a vision API. This is a pre-trained API, so you don't need to train it. You don't need to supply data. You can just call it as is and feed it your images. So let's look at an example of this. If you search Vision API, Google Cloud, you'll get to this product page where you can find more information, but also you can play around with a live demo. So I'll upload an image of the most common site in London, which is a pub. And what the Vision API will do, it'll actually do something very cool that no other API can do, or at least any API I've seen. It's going to leverage Google's knowledge graph so that if what you've taken a photo of is a business that's located using like Street View or something, if it's part of Google's knowledge graph, it can visually detect it. So it's not looking at any other metadata of the image. It's just looking at the visual image, and it says, this is this pub just around the corner from me. So that's one thing that's really cool. It's kind of a quirky feature. Like, it's kind of hard to think of, okay, what's a practical use case of this? But it's a cool feature, so I'm not going to complain. More useful features are things like detecting if there's faces in an image. So if we're trying to maybe ensure that someone hasn't uploaded any PII to our website, we can use this API to detect, oh, we've detected faces in the image, so let's not let that be uploaded. And this API will do that for you automatically. Maybe we want to take it a step further, so like being hypersensitive to PII, so not even any just bodies in general. It has object detection built right in. So if there's a generic object that you want to detect, maybe it's buildings, doors, cars, that sort of thing, this API can just already do it. So it's been trained on a whole host of different generic objects, and it can detect easily. This one is detect loads of persons and doors and some chairs. Maybe you don't want chairs uploaded to your website. I don't know, but this can help you do that. Then it's got generic labels. So if you just want to make your images easier to search, you can feed it the image, and it's going to just give you generic labels that you can then feed into your database and map to do a quick image search based on labels. Then it's got a powerful OCR feature. If there's text, maybe you want to upload a document and extract out the text. We actually have other tools that are very specialized to document processing called Document AI. So if that's something that you need to do, look into Document AI. That's a good tool to know about. That might be more complicated or more complex. But if you have a more complicated use case, then that's going to be good. If you just want to extract out like just a single piece of text from a single image, this API will suffice. Then other generic things, properties, but also really, really useful thing, safe search. So this will identify if the image is inappropriate. So you don't need to train your own sort of toxic image detector. You can just use this one. So preventing people from uploading inappropriate images into your service. You can call this API on the image before it gets uploaded and then block it. This is an example of a task and app-based tool. You can use it for one-off. It's just an API call away. And then it can also run at scale on thousands, millions of images. Good for tasks and good for apps. Again, pre-trained, you don't need to supply your own training data to it. But let's say you did. Let's say you did want to train your own custom image model. Well, you might think I was going to talk about an AutoML model. I'll talk about that later. I want to talk about a tool that's actually free to use and incredibly fast and easy. That's going to enable you to build your own machine learning models right now. So I believe if you haven't heard of this tool, I'm so excited to share it with you, because within the next 5 minutes, I'm going to show you how you can train your own vision models immediately for free using the web browser. So if you search for Teachable Machine, you will get to this website. This is a tool that Google released a few years ago, and it's just a golden gem of machine learning and showing it off. So what I can do is, we have a couple of projects we can detect. We can do images, we can do audio, we can even do pose-based stuff. But I'm just going to do a nice, humble image model. And let's say I want to train very relevant, well, not relevant anymore, thankfully. But maybe we want to detect if someone is wearing a mask before they walk into a building, maybe it's a clean room. And I want to train a model. Let's say it's maybe if you're within a startup, or if it's just like for a single laboratory, maybe you don't need to go through a whole research project. Maybe you just need something quick that's going to run on a Raspberry Pi somewhere, like something very simple, something that will just do the job. Well, with this, I can say, let's say no mask and mask. Here we go. So I'm going to select which webcam, hold it down, train some data. There we go. And then again, this is machine learning in action. And train model. The beauty of this technology, so it's using what's called TensorFlow.js. So it's a JavaScript version of Google's TensorFlow library, which is their machine learning library. And it all runs in the web browser. So there's no cloud connection. It's not sending any data to Google. It's just doing all this prediction and training all in my web browser. So now, in the span of 2 minutes, I have my machine learning model trained. I can play around. Maybe I'm prototyping this idea. Like, is it even possible to predict this? Turns out, yes, it's very, very predictable. And then what I can do with this is I can actually download this model and deploy it as a web app. So I've done sessions where I've walked through people where I've done this exact thing, copy and pasted this code, thrown it up on GitHub, and it's living as like a working app. So if you checked out my GitHub, you'll see loads of examples of like running apps that are built using this tool and just copying the code that's here. But cool thing to note about is that, yes, it's really good for tasks. If you've got something quick to do, even in hackathons, it's an excellent tool to know about. But you can also download this as like just the raw TensorFlow model. So if you just want to download the TensorFlow model, you could in theory then upload this to Google Cloud to run on Vertex AI and run at scale. So maybe you actually train like a really good, robust model using this tool, and you're like, okay, I want to put this in my application, download the TensorFlow model, throw it up onto Vertex AI so that millions of users can call it, or throw it into my Android app so that people can call it right within the app, or keep it as a TensorFlow JS model, have it embedded into a website. There's a lot of cool things you can do with this tool. And the fact that it's so easy to use and it's free to use means that you definitely should know about this if you're looking to play around with machine learning, because this is an example of one of those tools where anybody could fall down the rabbit hole of like trying to train their own image classifier and take weeks to do it easily. Even today, people will still go on a sort of chase trying to train their own model with whatever Python code. Is like, actually, you could do it in a couple of minutes. So it's good to know about it because it could save you a lot of time. So that is Teachable Machine. Really good for tasks. At a very stretch, you could potentially have this in a real public-facing app. But I think it's more useful for maybe internal apps for your company, because it's kind of hard to manage like data strategy with it. Like it's just data that you upload into the web browser. You can't have a huge data set. You can't easily maintain the data set or monitor its sort of performance scores like some of the other tools I'm going to show. Specifically, this tool, AutoML Vision, basically the exact same tool, but it's in the cloud and it's more enterprise grade. So the models you train with AutoML Vision would actually be more appropriate to embed in public-facing services versus Teachable Machine, which is maybe a bit more of a toy or a prototyping tool. AutoML Vision is the equivalent, but for production. So to show you that, it's basically the same interface that I showed before with natural language AutoML, but instead of uploading text, you upload images. This is an example of X-ray data set. So we've got pneumonia versus not pneumonia. And same as before, a couple of button clicks, and it will start training a model. I've already trained a model, so I can look at, here's some models that I've trained before. This is what was it, 5,000? I think it was 5,000 images in this data set. 5,000 images would not fit in Teachable Machine. Teachable Machine is only good for like maybe a couple of hundred images at most. Then it starts getting really slow. Beauty of AutoML, super scalable. So I can have as much data as I want in there, or I think it's up to like 1 million images or more. I train a model. It does a lot more work in finding the best model. It does stuff like hyperparameter tuning, data augmentation, all this stuff that you don't need to know about because it's doing it for you. And at the end, we have actual sort of better scores. We get better insight into the model. This is why it's much safer to use this for production versus Teachable Machine, which is more prototypey. But then let's say, okay, yeah, the performance is pretty good. Let's test it out. So we've got an endpoint created that can be called by thousands of users. And we can feed in and test out prediction. So let's see, does it give it the result we want? Yeah, this is actually a pneumonia image, so it detects that correct. Cool, we've got this API now. We can embed into our systems, applications, run at scale, run batch predictions on it. So yeah, that's really important tool to know. If we want to build an image classifier and it's just a quick prototype, Teachable Machine is excellent. If we then want to take that further and build it into an enterprise grade, production grade model, then we can use AutoML Vision. And AutoML Vision also enables you to download the model and run it locally on devices, but natively post it in the cloud. Those were image problems, my favorite. Next, tabular data, structured data. Let's assume we've got data about events that we're running, and maybe we want to predict the number of attendees. We can ask ourselves, is this a task or is this an app? Well, if it's just like for the next couple of events, maybe we just want to do it quickly using a spreadsheet. Well, I have the tool for you. Google recently released a tool called Simple ML for Sheets. This is really, really cool, because genuinely a couple of months ago, if I wanted to do this task, I would have to start writing some Python code to solve this, or use AutoML for a simple task, which probably wouldn't be appropriate. With this tool, this is an example of another free tool that's good to know about. Within Google Sheets, if you go to extensions, add-ons, get add-ons, and then search for Simple ML, you will find this tool, and it will exist like this. This will then be within your spreadsheet forever. And let's assume we've got some data. So I know I said the problem was like events-based problem, but we can run this on any tabular data. And there's a very popular data set called the iris flower data set. If you've ever played around with machine learning, you might have come across this data set. All it is, it doesn't actually show the data there, but I do already have it. Let me import it. What it is, it's a data set of 150 flowers, 3 different types of flowers, and 4 different features about the flowers. The 4 features are features about the petal dimensions. So the problem is, how do we predict the type of flower based off of the width and length of their petals? So we have sepal length, sepal width. Hopefully this is visible. I'll zoom in a bit more. We have sepal length, sepal width, petal length, petal width. We have these 4 features or inputs to our problem. So we're saying, given these inputs, I want to predict the variety of flower. And there are 3 varieties in this data set. There is 50 examples of a virginica flower, a versicolor, and a setosa flower. 50 examples. Okay. Let's imagine these could be features about our events. These could be the locations of the event, the time of day. It could be the topic. All these things could be here. And then this last column could be the number of attendees. So whatever is in the last column is what's going to be predicted based off of all the other columns. So we can translate this to virtually any other problem you have in a spreadsheet. But let's actually solve this problem. So I want to predict the type of flower based off of the dimensions of the flower. So what I'll first do, because these are all in order, it's already pretty easy for me to predict. So if I remove like all the setosa here, I know those are all setosas. So let's make this problem a bit harder. I'm going to shuffle these rows. So I'm going to highlight these all. Go to my tools. I think I've got a thing called Power Tools. Check this out. So I found another extension which can make this randomized. So just to make it a bit more compelling when I predict stuff. So I'm going to shuffle the data. Shuffle entire rows. Cool. This is just going to shuffle the data around so it's a bit more interesting and harder to predict where the things are just based on the row. I want to be able to predict based off of the data. And then what I'm going to do, these last couple, maybe the last, 20, I'm actually going to cut those out and bring them to another sheet. So we're imagining the problem is, here's all the data of previous events or all the previous flowers, and I want to predict the future events or the other flowers that I don't know the type of. So classic machine learning. We've got inputs, we have answers, and then we have inputs with no answers. So we want to predict what these answers are. Without writing a single piece of code, I'm going to go Simple ML for Sheets, start. Script attached needs your permission. It can have my permission. I'm more than happy to give it the permission because it is going to do things for me. Here we go. Extensions, Simple ML for Sheets, start. What would have taken me maybe at this point in my career, maybe I could have solved this with Python code in an hour, but I can instead just come here and say predict missing values. It's already detected. You want the last column? Yes, please. I want it to use the other columns. Yes, please. And I'm going to say predict. It's going to go through, aggregate all the data, train a model, and generate the predictions of the flowers. So we come down here. Here we go. So it's predicted these are the flowers or the flower types based off of this data, based off of the pattern that it's found from looking at this data. So it's only used the complete rows as training data. It is then only trying to predict on the rows that don't have the answer is already there. So let's go back to our true answers. I'm going to copy these back over so we can actually compare and see how many I got right. So I'm going to zoom in here. Get out of the way. So this one got correct. I'm expecting to get a couple wrong because the problem is not actually perfectly solvable because there's some overlap. There we go. Got that one wrong. This one correct. This one correct. So look at that. In the span of a couple of minutes, without touching any code, it's predicted with one wrong all of the flower types for our data. So that is called Simple ML for Sheets. Very powerful tool to know about because I remember my startup days, there was just some things you want to do quickly. And this tool can also be used for doing quick forecasting. If you've got sales in a spreadsheet, built right into the tool, we've got sales forecasting. And that's for free. So that's straight in there. And again, great for tasks. If you need this to then run on millions or billions of rows, it's not going to be good at that. That's when we can look at the next tool, which is AutoML tables. I'm not going to go back to AutoML. It's the same exact interface as before, where I showed it with text and images, but you upload tabular data. And because it's AutoML in the cloud, it's a lot more scalable. So this is going to be able to take millions of inputs of data, and it's going to be able to train a more robust model that can either be run with batch data or run in real time as it's hosted. So thousands of people can call it at the same time. But if you just got a quick task you want to do, you can do that with Simple ML for Sheets. If you've got a more advanced application you want to build, you can use AutoML tables. And on that, there's another tool. We basically now have AutoML tables integrated into BigQuery, and it's called BigQuery ML. BigQuery is our data warehouse tool. So you can put trillions of rows of data, actually trillions, maybe. You can put a lot of data into BigQuery. And with just now SQL commands, you can train AutoML models to run in BigQuery, almost like the way Simple ML runs on Sheets. BigQuery ML runs AutoML over BigQuery. So if you're like, oh, I've got loads of data in my BigQuery table, and I just want to maybe predict the missing rows in it or build something there without having to move data around, you can use BigQuery ML, and it will effectively train an AutoML model on the BigQuery data and enable you to predict on future BigQuery data or export that model into Vertex AI to run as part of an application. Now, that was a lot of stuff I just said. The important thing to note, simple stuff in Sheets, Simple ML. Stuff in the cloud, AutoML tables. Stuff in BigQuery, BigQuery ML, if you want to predict on it. Next section, videos. Now, this is a unique problem space that I also like working in. So let's assume we have a video that needs to be programmatically edited to remove all the swans from it. Swans are vicious creatures, and I've got a friend who is insanely scared of them. This is a true story. So I had the idea, let's see if I can use machine learning to help solve this. First tool to know about, especially when working with ML and video, is Video Intelligence API. So coming back over here, this is, well, actually, if you search for Video Intelligence API, you will get to the Google product page for that tool. Now, unfortunately, unlike the other product pages for the natural language API and the vision API, this one doesn't have a demo built into it, but no worries because I've built my own demo that is also publicly accessible. So this is just visualizing everything that the Video Intelligence API does. So all the different features that happen. So it's basically got the same features as the Vision API, but applied over video. So the Vision API could detect simple labels in an image. This can do labels throughout the video. So maybe we come down here and we see these are the labels. So if I click here, I visualize. Yep. It's identified, oh yeah, there's a bridge from this section to this section in the video. So any kind of generic object types, it can automatically detect. With no training of your own data, you just feed it a video and it does all these things for you. The next interesting feature is the shot detection feature. Kind of cool to know about. I've had a few use cases where I've actually found this feature really useful. And all it does is detect when the camera changes scene or changes shot sharply. So you can see when it changes now, you can see it shows all the different sections. So maybe you want to analyze, commercial breaks in video. This could automatically detect all the different commercials in the video. Next really useful feature, very common, I think the most common feature people use, object detection. So not only is it detecting objects, but it's actually doing tracking as well. So if that object moves around the screen, it will give you the JSON file or the JSON objects that show this is an object, it was here at this timestamp, and then it was here at this other timestamp. So it does object tracking of generic objects throughout a scene. Next one, a bit more specialized version of object tracking, which is the person detection. It does a similar thing. It detects the people and tracks them throughout the scene, but it also does a bit more granular detection. So anytime there's like joints on the body, so the elbow, shoulders, knees, and toes, that sort of thing, it will automatically detect those places and also track those. So I've used that a lot for sports use cases. So in the football or soccer demo that I built earlier, I used this person detection to detect like the angle of the kicker's leg as they were kicking. So it's a really cool feature to know about if you're doing any kind of fun sports use cases. Another granular detection is the face detection. So it's doing something similar, but it's detecting just the face. And then it's detecting a few extra features, like if the person's wearing glasses, if they're smiling, if they're looking at the camera. I haven't built anything around this use case, but I think it's a cool feature to know about. You never know when you might need that feature, and it'll save you a lot of time trying to train your own custom model if you can just call this API. Another cool one, logo detection. Anytime there's a business logo mentioned in the video, it's leveraging, again, Google's knowledge graph. So obviously it detects the Google logo pretty well, but we can automatically detect maybe branding that's happening inside a video, all just by calling this API. Speech transcription. If you want to just work out what people are saying in a video, you can use the speech transcription feature. Text detection, it's running OCR throughout the entire video. So you get a lot of stuff back because there's usually a lot of random stuff in videos that looks like text. So yeah, any text, it's detecting and also tracking. And then again, safe detection of the video. So how likely it is for featuring explicit content throughout a video. So if anyone's trying to slice in like a bit of inappropriate content in a video upload, this will automatically detect it. Okay. That's the tool. That's the API. You can call this from different programming languages. And how I've used it is I've used it to automatically detect swans and remove them from videos. So the way I've done that is in Google Cloud, I've created a cloud storage bucket. And I've had a bucket where I can upload the raw terrifying video. This is a video with a terrifying native swan appearing. There. Vicious. And what happens is when I upload that video, I have a cloud function that is basically just a block of code that is productionized on Google Cloud. And within this cloud function, I have the code to call the video intelligence API. So there's a bit of Python code. This is, I think, just these 2 lines. This is the call to the API. So instead of train your own model and all that stuff, 2 lines of code, I can call video intelligence API to analyze my video, and then it will output the analyzed video into another cloud bucket. Once it's done that, if it's detected a swan, which I hope it does because it's a pretty generic object, I can say, okay, for the bits that feature a swan, use a bit of Python code to programmatically remove those. So over here, this is our fixed videos, and it's got the same video that's been uploaded, but the section where there's a scary swan, look at that. And I've kind of made this very dynamic, so you can define anything you're afraid of and have it removed. Maybe you're afraid of, what else was featured? Bridges. You could remove those. It's an example of how I basically built this system. This was, I would say this qualifies as an app at this point, but this is just by gluing a few things together. Got the video intelligence API, some cloud buckets, and a cloud function. Each of those elements are super scalable. Cloud buckets can post as much data as you want. Cloud functions are serverless, so if one person uses them, they'll just spin up to serve that one user. If 1,000 people start using them, they'll spin up to feed that sort of load. So yeah, very powerful things to know about, because now I can use this for a one-off video or 1,000 videos, all without having to think about scaling. So yeah, good for tasks and good for apps. But maybe we have a bit of more custom thing. let's say it's not a swan, it's maybe a specific type of swan or a breed of swan, or it's your specific product you want to detect in a video. We have AutoML for video intelligence. I'm not going to go into AutoML again. We've already seen the UI time and time again, but it's the same sort of thing. I can upload my videos into Google Cloud. I can say, here's the things I want to detect throughout the video. Click a couple of buttons and it will train a video classification model that's custom on my own data so that I can use it to serve my own applications and services. So we've covered video, we've covered text, tabular, covered all the use cases. I now want to end with a sort of big demo that combines a lot of different tools and also one of my favorite tools to know about, which is a searching tool. So let's assume we have this problem, and this is a real problem. So inspired by a friend of mine who's an artist. She's actually from Montana, so shout out to people in Montana. She is an artist and she makes abstract art, and she asked me, or she was telling me how one of the problems she faces is trying to find the right galleries to feature her pieces of work in, because if you're trying to sell art, it's good to have it next to similar art. I'm like, oh, that's an interesting problem that artists face, but there's no real like solve for that. Nobody's made like a special search engine until now. So we've got Vertex AI matching engine. This is very cool because it uses embeddings. I'm sure some of you have probably heard of embeddings and that they're really cool. Those of you that haven't, I'm going to explain them all. And it's a very cool technology. It's basically what's fueling this amazing uptick in AI technology, because having stuff represented as embeddings enables a lot of really cool things to happen. So let me talk you through what embeddings are and how to actually use them for practical application. So here's an example of my friend's work. Very hard to describe. I don't know how to describe it, but I'm not an artist. Let's talk about embeddings, because embeddings might be able to describe it. So they're also known as feature vectors. In classic machine learning, we may have an image feed into a model, and the model then output flower. So a single text label or whatever else is in the image. It might just output that. That's classic machine learning that we're used to using. In embeddings, instead of it outputting a single thing of like, this is what's detected, it instead outputs basically a lot of random numbers. Now, these numbers don't make sense to humans just by themselves. But what's really interesting about embeddings is that if you feed in a similar image, these numbers will actually be kind of similar. So these numbers basically represent how the AI is interpreting the data that you're feeding it. So it can actually kind of work out that, oh, this is a flower-like image. But let me give you an example. Here is a lot of images. Click here. Here is a lot of images that have been embedded using an embedding model, and then they've been plotted based on their embeddings. So if their embeddings are similar, they'll be physically close together in this plot. And if we look closely at it, we see that, okay, over here we have some birds. There's some white birds over here. Maybe here's some birds with long legs here. There's some eagles. Oh, American eagle. There is, here we go, down here we get some monkeys. Over here we get some like foxes. There's like a red panda. We got some lonely hamsters over here. I don't know what this is, but it's by itself. And then we've got these sorts of dogs. There's a dog with that like funny hair. There's some hamsters and cats. But all in this corner, this is a cool corner to come to because it's got all the dogs. If I go other places, we've got, okay, there's people there. I hope those people all have clothes on. And then we've got sports happening over here, some baseball, and then some bikes over here. So the thing to take away is similar images have similar embeddings, and we can actually see them physically close together. And the really cool thing is that this machine learning model wasn't trained to detect all these different types of sub things. It was probably trained to be a lot more generic, like this is a dog. But by looking at its embeddings, we can actually work out that this is a dog that's similar to these dogs, but different from these other dogs. So it's really cool. It's really cool how it's able to see like similarities that we haven't actually trained it to see. So that got me thinking, it's like, I could potentially use this for working out art similarities. But how we can actually use is an algorithm called nearest neighbors. So if we were to take all those images, those are represented on the 2D space as we showed before. And let's say we upload a new image and it appears in our 2D space there. The nearest neighbors algorithm will work out what are the closest points to that new point. So it's basically doing a physical search or a spatial search around, given this point and all these other points, what are the closest points to this point? And if these points are embeddings, and these embeddings represent our data like images, we now have a similarity image search. And this is exactly how reverse image search works on Google, where we can upload an image and see all the similar images, because they're using embeddings. And it's the same kind of technology that's powering other types of search, like just normal Google search and YouTube search. That's all powered by embeddings because it's a lot more powerful and a lot better way of relating data to each other. So that's nearest neighbors, that's embeddings. We can embed anything as well. We can embed images, text, anything that basically structured data is already embeddings. You can think of it, but we'll not get into that. How did I build this search engine for my friend? First, I got some data. So I searched all of the galleries in the UK for galleries. And as part of the Google Maps API, you can actually get the images that are related to that place listing. So, when you look up a place like a restaurant or something, you see photographs, you can actually fetch those and download those. So I've taken all those for the galleries in the UK and embedded them. Then to actually embed them, because this is running at scale as an application, I've used an embedding model and I've uploaded that to Vertex AI to host. So what's really cool is, like I said before, the embedding models don't need to be specific to your use case. I actually just downloaded a generic embedding model from TensorFlow Hub. So they have free models that you can just download. And because I wanted to run it at scale, I then took that model and uploaded it into Google Cloud Vertex AI, where it can actually host the model to allow me to serve it from an application, but also to allow me to run like batch on it. So if I wanted to run 1,000 images and get embeddings for them, I can have it in Vertex AI and run a batch job on it. That was getting the embedding model. So I downloaded that from TensorFlow Hub, upload it to Vertex AI. And then all those embeddings I fed into Matching Engine. Now, Matching Engine is what's going to do our nearest neighbors search for us. It is a vector database that is specialized in doing exactly this. So given embeddings and giving new embeddings, find the nearest embeddings. So it handles the vector search for us at scale. So this is an application thing. You don't really want to be spinning up Matching Engine for a quick task. It's a heavy duty tool that's it's based off of the same technology that powers Google search. So if you've got a serious search application, Matching Engine is probably a good tool to look into. That was building the database. To actually use it now, we've got a new image, embed it, and then query Matching Engine. That's all the talking. Let's get on to the demo. So very proud, I got this domain called findmy.gallery, public domain. So feel free to go and play around with it. I'm going to go to it now. Findmy.gallery. Let's hope it still works. So I can click on any of these images. Let's say I want to find images like this one. You can see how quick it is. It vectorizes it. So here's a visualization of that embedding. So I think it's like 1,000 numbers to represent this image. And then here is the results from the listing. So this gets 100% match for this one because it is the same image and the gallery that it's for. Here's another one that's similar. Here's another one that's similar. And you can actually click through these images and kind of like walk through all the galleries in the UK by just what you fancy in terms of visual art. But let's say I'm interested in like bones. What's really cool here is like if I were to compare these images like pixel by pixel, it wouldn't make sense. Like these images are completely different in terms of pixel colors, but visually they both contain this kind of item. That's what the embedding model has worked out. And Matching Engine has realized that, oh, these embeddings are actually similar, so let's return them. Let's even return like the same image, but from a different angle. So it's like 1% less relevant. But not only can it work with the images that are uploaded here, like maybe I mentioned statues, I can upload a piece of my friend's art. And we've got something similar. This thing is circular. This thing is really kind of similar in its like vibes. These are all kind of similar vibes. Yeah, you can just play around for ages on this, just finding like random pieces of art. But that's an example of practically how do you glue these things together to build a powerful tool. Like this is definitely application. This is all running at scale. I'm assuming people are already calling this within this talk, and you can see it doesn't hiccup at all when I'm using it. And that's because it's powered by Cloud Functions and Matching Engine, both super scalable in terms of their users or their uses. But yeah, that is the crux of the talk. Thank you all so much for listening. I hope you all heard about at least one new tool that you didn't know existed and didn't know it was as easy to use as it actually is. The main takeaways are identifying and being intentional with what machine learning tools you think about using for problems, and identifying what's the simplest tool to use, and identifying if it's a task or an app, because that should define which tool you use and make it a lot easier to decide. So yeah, thank you all so much. I'm going to answer some questions that are in the chat that have been coming throughout, and then we can call it a day. So the first question is, can machines truly comprehend? Oh, this is a deep question. Here we go. Let me get ready for this one. Can machines truly comprehend human language, or are they simply mimicking intelligence through machine learning algorithms? That is a good question. Can it truly comprehend human language? The thing to think about, this is almost getting philosophical, is define truly comprehend, and then we can like discuss it, because it's the kind of thing is like, as soon as you define it, some engineer is going to probably find something that matches that definition. So do I think personally that it truly comprehends human language? Kind of. But then again, I'm just like a simple engineer, so I like to think everything is solvable with algorithms. So I think there is mimicry in it, absolutely. But then as a human, I kind of mimic stuff as well. So yeah, do humans just mimic stuff and then delight to things truly comprehend? Like, what is understanding? Anyway, yeah, it's an interesting philosophical question. My answer is maybe. Question from Carlos. Another one. Oh, that question was from Carlos. Another one. Can AutoML be used for personalization? So that term personalization, that seems could cover a lot of things. I'm assuming, well, I'm going to make the assumption that personalization refers to personalizing content. So can you use it to potentially make like recommendations? And I would say yes, because you can effectively take unstructured data that you don't know is good for someone, use AutoML to classify it, to say what is in this data. And then if you've got user profiles, you can say, okay, this data is good for you. I would say that is like a recommendation problem. So I think it's more almost Matching Engine could be a better tool for that, because it can see similarities and like, oh, this person, like if we represent them as this embedding, this data kind of is similar to that. So they could look at that. But we also have a thing called recommendation AI that is a useful tool to look at. So that's built into Google Cloud, and it's basically a recommendation engine as a service. So if you're looking for customized sort of user journeys or recommendations of products based off of user profiles, look into recommendation AI, because that might actually be a way better tool to use. Another tool, what if I want to analyze one species, say a bird? Could SimpleML analyze what type of bird it is by supplying the characteristics of the sample bird and a large set of characteristics of a population of birds? Okay. Yes. Or if you've got data about birds in a spreadsheet and you want to predict them, do we want to analyze one? So what's interesting, the word there is analyze. It's like, what do you want to analyze? Do you want to detect if these species are like what these species are? Or if you want to cluster them, that's a different type of analysis. I'm not sure on, I think, did SimpleML, let me just quickly check here. Does it have clustering? Because clustering is spot on abnormal values. That's a cool thing you can do with analysis. So if you've got already a data set that you don't want to predict with, or you don't want to just say predict it's this, predict it's that. Maybe you just have lots of data and you want to say what's abnormal about this data. That kind of analysis, yep, you can totally do that. Maybe it's you've got data about the breeding rates of birds over time. You've got forecasting. You can analyze that. Or if you just want to predict what the bird is or some feature about the bird, and you've got data for that where it's here's the features that we know and here's the features that we don't, then you can use the predict missing values. So depending on the analysis task, yes, this should be able to help if you've got the data in a spreadsheet. But I invite you to play around with this. Again, it's a free tool, so just install it and then use it at your leisure. Another question. Question. Do we need more? How can I do logo detection using Google ML? The Vision API should already do logo detection out of the box. The example I showed, those features that show up, so in this Vision AI thing, so these features, I tried to find an image which would trigger as many features as possible because these are, they kind of appear when they're triggered in the image. So there's more features that aren't even being shown here, and one is like, yeah, logo detection. So that should be built into the Vision API, so you can just use that as is. So yeah, look into the Google Cloud Vision API. How can I do that? Yeah. So that looks like it was all of the questions. Let me come back to the questions page, and hopefully that shows on the screen. So here are some of the links for some of the things I've talked about. Feel free to ask me more questions on LinkedIn. You can add me with my name, Zach Akil. And yeah, I wish you a good rest of your day, and thank you all so much for stopping by.